In this video, we want to find the area of the region between the curves f of x and g of x. F of x is a cubic equation, and g of x is a quadratic. The coefficient of the squared term is negative, so this one's going to open down, something like this. And then the cubic equation, because the coefficient is positive, and it's degree 3, which is odd, it's going to go down on the left side and up on the right side. So it's going to go something like this. So we're looking at the region enclosed or between the two curves. So they're looking at this area here and this area here. We're going to use, of course, the definite integral. And first we need to find the points where these two curves intersect. So we just simply set these equal to 0, or set these equal to each other, I should say. X cubed minus 2x squared plus x minus 1. Set that equal to the parabola. Got minus x squared plus 3x minus 1. And then we collect terms to the left side, make one side 0 here. So the x cubed will stay over here. The minus x squared comes over, makes it a plus, so 1x squared and a minus 2 gives me a minus x squared. 3x comes over, minus 3 becomes a minus 3x, and x is a minus 2x. A minus 1 comes over, makes it a plus 1, so these cancel out here. And we've got this equal to 0. And now we factor an x out of this trinomial. We get x times x squared minus x minus 2. Now we've I guess we have to factor this further. So x squared minus x minus 2 factors into x minus 2 and x plus 1. Now we set each factor equal to 0, so that tells me that x can be 0. That's, of course, it's a solution to this equation here. X minus 2 is 0 at 2, and x plus 1 is 0 at negative 1. So these are the first components of the points where the graphs intersect. So let's find where they intersect. Let's do negative 1 first. Start with the leftmost point, so negative 1. You can plug it into either one of these, because this is where they intersect. So negative 1 here, squared is 1, and a minus gives me a minus. And then minus 1 here, and the x is minus 3, and minus 1, so minus 3, minus 1, and minus 1 gives you a minus 5. So one point where the graphs intersect is negative 1, negative 5. Then 0. Plug in 0 here, here, same thing, 0, 0, 0, get negative 1, 0, 0, negative 1. So the next point would be 0 and negative 1. And then finally at 2, put a 2 here, that'll be 2 squared is 4, and a minus 1 is a minus 4. With a minus 4 here. And then 2 here gives me a 6. So that's minus 4 and 6 is 2, and minus 1 is 1. So it's just 2, 1. So we know the graphs are going to intersect at those points. Now you can go ahead and do a rough sketch of the graph and generate the integrals, the definite integrals needed. Or you can go to your calculator. I've already entered the functions. This is your cubic here, your parabola. I had graph here. That's what the graph looks like. So you can see that out here you can't really tell, but there's a region here. There's a region over here. So we're going to need two integrals. One to get this area here on the left, and then another integral, definite integral, to get this larger area. And then the sum of those will give me the area, total area. And I've kind of set this up already. The red curve is the parabola. And one point of intersection is negative 1, and then we go down over here. It's a rough sketch. Negative 1 and negative 5 over here at the bottom. And then, of course, 0, negative 1 is right there. Across the y-axis right there. And then 2, 1 is over here. So basically we're going to go from negative 1 to 2. But first we're going to get the integral from negative 1 to 0, right in there. Then the second integral will go from 0 to 2. And remember, on these, it's always to get the rectangular strip. So here we work with one rectangular strip here, and then one here. And it's always the top curve minus the bottom curve. Top minus the bottom. So here it's going to be the curve, the cubic, right here. So this will be f of x. For this one, we're going to have f of x minus g. And for this region here, it'll be the opposite. It'll be g of x minus f. Okay? Top minus the bottom curve. So f of x minus g of x. So it'll be x cubed minus 2x squared plus x minus 1 minus the g. And then for the second one, it's just reversed. It'll be g minus the f. And I've set those up here. So the total area over then, after I do the subtraction there, I get this for the first one. From -1 to 0, do the subtraction. And the next one from 0 to 2, again subtract the two curves. Top minus the bottom. This is what we get. And then it's just basic integration here. This is going to equal to then, these are just monomials, polynomials, and so forth. So for the first one is x to the 4th. We add 1 to the exponent and divide. So it's x to the 4th over 4 minus x to the 3rd over 3 minus, again, 1 to the exponent, it says squared, and divide gives us a minus x squared, and this is evaluated from -1. This goes from -1 to 0. And then it's going to be plus, same thing over here, add 1 to the 3, we get 4, and then divide. And to the x squared, add 1 to the exponent, gives me a x cubed, divide by 3 then. Then 2x again, add 1, we get x squared, and I divide by 2, we get 2's cancel out, we get this. And then this is evaluated from 0 to 2. Then it's just a calculation then. So then we evaluate this expression at 0. So 0, 0, 0. So that'll be 0. And then we subtract the value at the lower limit. So -1 there will give you a 1/4. -1 squared to the 4th will be 1. Minus 1 here will be a plus, because the negative here. 1/3. And minus 1 there, that'll give me a minus 1 squared, and then it's a minus. There's a minus here. And then it's plus. The next one, evaluated 2. This will be 2 to the 4th is 16 divided by 4. It's 4. And then I have the negative. Minus 4 there. And then 2 here, plus 2 to the 3rd is 8 over 3 then. 8 over 3, and then 2 squared is 4. And then it's minus the value at 0. Because they all have an x, that's just going to be 0. So this is going to be in 0, then we get a minus here. Let's get the same denominator here. This will be 3 over 12. Plus 4 over 12. Minus 12 over 12. Just getting the same denominator. Combine this, we get a minus 5 over 12. And then over here, minus 4 and the 4 cancel out. So I get 8/3. Double negative here, I get 5 over 12. And let's get the same denominator here, multiply by 4. So this will give me 32 over 12. And then we just had these. 5 plus 32 is 37 over 12. And that's the area of that region. Actually, it's the two regions. So that's the area of the region between the curves. Thanks for watching. We'll see you next time.